viewers and my dear students, welcome to session 2 on problem 2 demo on use of CAM software, that is EdgeCAM, for generation of G&M codes for taper turning and groove cutting profile. That is, in this session 1 I have already shown CNC taper turning and groove cutting video tutorial, that is using EdgeCAM. That means the design phase is already completed, the design phase, and even we have come to the manufacturing phase. We have selected the different tools. We have done the operations for taper turning, that is rough turning, finish turning, rough grooving, finish grooving. Everything has been done. And as you know here, I'll just show you. This is the problem given for, and these are all the things. And for these coordinates only, for absolute, for with this as the origin, I've got all the coordinates here. With reference to this, I have done this in the design mode. Okay, in the design mode, I have got all the points here. Then I have switched over to this manufacturing mode. Okay, I've switched over to the manufacturing mode, and as you see here, once you switched over to the manufacturing mode, okay, these things I've already done. Turning tool, rough turning. You see here, rough turning. That means only facing. Then turning tool, rough turning. That means OD turning. That this tool path we already drawn. Okay. Then finish turning. That means finish turning. Clearly you can see this finish turning, how exactly it has done and all that. Finish turning also you do. Then grooving tool. Okay. Rough grooving also you have seen. Okay. Now rough grooving, if you see, this is 0.3 mm. No. From it starts from here, it ends here, and also it leaves an allowance of 0.5 here and 0.5 at the bottom also. Okay, and grooving tool and finish grooving also you'll see. That means removing the 0.5 on Z and 0.5 on X. These things also I do. Now up till here we're done. Now what you have to do is you have to simulate this. Simulation we'll do it. You see here. When you do the simulation here, it takes time. As you know here, there are so many operations to be done here. As a result, it takes time. This is, you have first facing, then that is rough facing, then rough turning, then finish turning, and rough grooving, finish grooving. There are so many operations. Now you see here, this we have done. Now keeping the right, you can that is change it to any isometric mode and all that. You see here in the output you can see. And in the speed control, you see here speed control, you bring it to the minimum and start simulating. You play this pattern. Okay, now slowly you can increase it if you want. You see here. See, now it is all doing the simulation. Now it starts cutting the face. That is facing we have done. No, it starts facing. Now it has started facing. Okay. And when facing gets finished, it would have left an allowance of 0.5 on this face. Extra material of 0.5 will be there. That is removed during finishing. Okay, slowly I'll increase the speed also. See here. In that way, now we are going for OD, outer diameter. See here, now it is, you see here, this, now we are doing operation on the outer diameter. Okay, this is OD turning, outer diameter turning and all that. You see here, rough turning is already over. That means that is on facing is already over. Now it is doing the rough turning. In the output you can say what exactly is happening here. Now you see here, already one step has come. That means this is actually 100 diameter. No, now leaving an allowance of 0.5 means actually this will be 101. That means during finishing the depth of cut will be 0.5, so that this will be 100. Okay, 0.5 will be the depth of cut. As a result, it will be 100. Now, this diameter, as you know, it is 101. Only that 0.5 will be removed during finishing so that it becomes 100. Because 0.5 mm aligns here as well as on the bottom. That means top and bottom you would have given. When 0.5 is the depth of cut, automatically diametrical reduction will be 1 mm. This 101 will become 100. Okay. Now it is doing the taper turning and all that. You can clearly see. A little bit increase. This speed control you can always increase. If you want to increase or decrease, okay, you can always do using the speed control only. That main button is here. If you operate this, this will come and you can control the speed control using this. Okay. Now, as you know here, this diameter will be actually 52, but during roughing, this will be 53. And during end, that is finishing only, now it is here, finishing, it is that 0.1, that is 1 mm is removed here. Okay, now you see here, this rough grooving is also being done. Slowly observe. Okay, that finishing is also over. That is finished is here. Rough turning, finish turning, okay, rough grooving, finish grooving, all procedures have been done. Okay, this you see here. Now, initially it will be 53. After finishing, it becomes 52. Even here also 53, 52. Even here also, as you see here, this will be actually 101, and it will be during after finishing it will be 100. And even here also, see here, this actually it is 41 it will be, okay, 41 it will be after roughing, and that is this diameter. After finishing it will become 42. Okay, in that way even this grooving is also done. And even Z also from here to here, if you see here, it is actually minus 70. Minus 70 means during roughing it will be actually 69.5 from here to here, and after finishing it becomes 70. And even here, from here to here, it is actually minus 120. That means 119.5 it will be. After finishing it will become 120. Okay, in that way you see here, this, if you want to redo this, if you can do this button you press, and again you can start the simulation. And if you press this, whatever we have done you get. Okay, in that way you practice all this, and if you want to redo, you can redo. You have the entire material, you can do the simulation again. Okay, this is one important thing what you should know. Now another important thing here is this simulation mode. This is another very important thing what you should never forget. This simulation mode, you will know what exactly is happening here. Now simulation mode, simulation speed 30 you take, just say okay you say. Then compulsorily put to tracking you come. Okay, now you see here, that is facing it is doing. You see the Z here. After 0.5 it will go up. Now it is 6.92. 6. You can increase the simulation speed also. That is, I given say 30 there. Okay. Now I can increase the simulation speed. Now see here, Z 2.233, 1.42, and it will be 0.5. You see here. Now it is 0.5. It will go off. Okay. Now it is going for OD turning. OD turning also you keep observing. Now once OD turning, this X you observe. X it actually is 100, no? 101 it will be. Once 101, it will go for the remaining part. You keep observing here. Now it is 109.66. That is, since increment we are given 1, every time diametrically it reduces by 22 mm. Okay, 105, 103 in that way. 103 you see here, 103, 101, 101 you see. Now it becomes 101. Okay, now that remaining 101 you see here, 101, that will be removed during finishing. Okay, now the taper turning is being done. You see here, taper turning is being done and all that. Okay, and you keep observing X. X actually it is 52, no? Here it is 52. You should know very well it will be 53. Okay, before finishing takes place, when finish turning takes place, this will be 53. Keep observing. This will be 53. Now X 84, 82. This tool path you see. This is a tool path. On this tool path given by CAM software, it moves exactly in this way. Even if this commands, that is in the G&M codes, this tool path would have been generated. And if you transfer it to any CNC machine, it goes in the same way. Okay, it goes in the same way. That is the advantage of it. If you see here, I given the cut increment as 1. That is why it is doing faster. If I had made 0.5, every time it is 1 mm diametrical reduction, it would have taken more. Now cut increment 1 I have given. As a result, every time it is decreasing by 2. Now you see here, this is X, you keep observing. X, it is 52. It will be actually 53. Okay, 54, keep observing this. This you keep observing. 52, it will be 53. Now you see here. Now the finish cutting is done. 52. Okay, and this will be 100 and Z is minus 20, X is 100 and all that. Now the rough and finish turning of this grooving is also being done. Okay, then finish grooving also is being done. Everything is over. In that way, we have completed the problem in all respect. Now you see here, file, you save as, file, save as, you save this file. Okay, file, save this file on desktop. Okay, this is important. Go to that. Paper and groove cutting. Groove cutting, you do this and save it in the desktop. Anytime you can open this. Okay, did you follow? Anytime you can open this and you can see the simulation, everything, whatever we have done, you will get it. Now you see here, the important thing here is generation of codes. For this complex profile, we have generated the profile, that is a generation of G&M codes. You see all defaults value take. Okay, now actually CNC name and all that you can give. Now we'll give the default values and we'll see the G&M codes. See here, while this manual part programming, I'll do in detail how these things are done and all that. Now you just see the how G&M codes have been generated and all that using EdgeCAM. You see here all the programmer's name, you take the default. This program description, all you take the default. Okay, now the G&M codes would have been generated. Now you see here, the G&M codes would have been generated here. You see here, once this is the G&M codes generated. This explanation, all that I'll just tell you, that is during manual part programming, you will know how exactly the G&M codes are written for this. Then you can compare with this. This is a perfect G&M codes what has been written for this taper turning groove cutting profile. This G&M codes have been generated. What you do is, okay, you just copy this G&M codes, you copy it and paste it in CNC machine. Okay, once you paste it in CNC machine, you are getting the same thing. Okay, that means the G&M codes, whatever has been got, you have to copy it and paste it in CNC machine. You are getting the same profile. That means the advantage what I am telling you here is, if the profile is complex, you don't have to write the program. You do the profile and go as per my procedure. Automatically G&M codes are generated. Use the G&M codes and get any complex profile on a turning workpiece. Did you follow? That's why G&M codes generation is this is the important thing for a CAM software. That means these days nobody will do the manual part programming. All will use any CAM software, generate G&M codes, load it to CNC, and any complex profile they'll get. Okay, now we have come to the end of session 2. Thank you viewers, thank you friends, thanks for watching. Thank you again.